Arduino board was created in Ivrea, Italy in 2005 by Massimo Banzi and David Quartielles. Arduino is an open-source physical computing platform based on a simple input-output board and a development environment that implements the processing wiring language. Arduino can be used to develop stand-alone interactive objects or can be connected to software on your computer. Arduino boards are able to read inputs, light on a sensor, a finger on a button, or a Twitter message, and turn it into an output, activating a motor, turning on a LED, publishing something online. Thanks to its simple and accessible user experience, Arduino has been used in thousands of different projects and applications. For example, Arduino is used in robotics, in human support, for playing, to experience. Teachers and students use it to build low-cost scientific instruments, to prove chemistry and physics principles, or to get started with programming and robotics. Arduino boards are relatively inexpensive compared to other microcontrollers platforms. The less expensive version of the Arduino module can be assembled by hand, and even the pre-assembled Arduino modules cost less than $25. The Arduino Uno can be programmed with the Arduino software. It runs on Windows, Macintosh, and Linux operating systems. The Arduino software, named IDE, is easy to use for beginners. The Arduino software is published as open source tools. The language can be expanded through C++ libraries. The plans of the Arduino boards are published under a Creative Commons license, so experienced circuit designers can make their own version of the module, extending it and improving it. Arduino Uno is a microcontroller board based on the ATmega328. A microcontroller is a complete microprocessor system integrated into one chip, designed to obtain the maximum functional self-sufficiency. The microcontroller includes, in addition to the calculation unit, also the memory, RAM and ROM, and additional input-output devices, depending on the specific application. Arduino contains also everything needed to support the microcontroller. Arduino has 14 digital input-output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a USB connection used for power supply from the PC and for data transfer, a power jack for external power supply, a pin for power supply from 6 to 20 volts, a reset button. Now we are speaking about the Arduino programming. To program the Arduino, we need a special software that will let us connect to the Arduino, so we can code it. This is the Arduino IDE. IDE stands for Integrated Development Environment. It just means that everything you need to code is all one place. Development stands for software development or coding. we use code to create programs. Environment is exactly what it means. In computer programming, an environment includes all the things we need to code our Arduino in its little Arduino world. Let's get started. First, we need to download the Arduino IDE. We use the IDE software to create a sketch that we upload to the Arduino board. The sketch tells to the board what to do. To connect Arduino Uno to the PC, we'll need a USB cable. Arduino draws power directly from the USB port, so we don't need to connect a power supply to it. The code we write for our Arduino are known as sketches. They are written in C++. Every sketch needs two void type functions, setup and loop. The setup is where we want to do, and in loop we want to run the code we want to run over and over again. All the objects we will build using Arduino follow a very simple pattern that we call the interactive devices. The interactive device is an electronic circuit that is able to sense the environment using a sensor, electronic components that convert real-world measurements into electrical signal. The device will then be able to interact with the world using actuators, electronic components that can convert an electronic signal into a physical action. Sensors and actuators are electronic components that allow a piece of electronics to interact with the world. Once the sensors have been read, the device has the information needed to decide how to react. The decision-making process is handled by the microcontroller, and the reaction is performed by actuators. In our bodies, for example, muscles receive electric signals from the brain and convert them into a movement. In the electronic world, this function could be performed by a light or an electric motor.